All right, I am now recording. Welcome. Today we're going to look at isomers, which is one of my favorite kind of topics in chapter one. And I mentioned a minute ago before I hit record that it can be challenging. So you might want to pay extra attention today when I'm going through isomers. It's a classic question, by the way, wink, wink. I know you can't see me wink, but if you hear me say wink, wink, if we were in a real classroom and I did that, it's a hint that you might see this on a test or the final exam, this question about isomers. We're going to learn how to draw isomers today, and it's really easy. It's like, um, I don't want to say solving a puzzle, but it's fun, it's easy, and I'll show you. So before I can get to isomers, just a reminder, we will be using the skeletal formula. I did this last class in chemistry 2420. We're not going to be using structural or even condensed structural. Like what I mean is we're not going to be drawing things like this. You can if you're crazy. You know, if I give you a question on a test, you could always do structural formula, but it's a lot easier to do skeletal, especially when we get into longer hydrocarbons, aromatics. Skeletal is the way to go. If any of you are still confused about skeletal, don't worry, because we're going to be drawing them for the next month. We're going to look at skeletal for alkanes, alkenes, alkynes, and aromatics. So you'll get lots of practice. Okay, so isomers. There is only one way to connect the carbon atoms in each of the alkanes so far, but there are multiple ways to connect carbon atoms in alkanes with more than 3 carbon atoms. Actually, and I guess that's a bit of a lie, because we could have isomers for pentane right here. So that's something I should change in my notes. But any carbon compound, any hydrocarbon, I should say, that has more than 3 carbon atoms, there are different ways to connect them together. The way in which we connect them, it's called connectivity. And you don't have to worry about that. But this you definitely need to know. Wink, wink. The definition of isomer. Molecules with identical molecular formulas, but different or distinct structures are called isomers. So they would have the exact same formula, you know, C5H12, but they would have different shapes. They wouldn't be put together the same way. And this is kind of, you'll see this in your first lab. Now, your first lab is not next week, it's the week after. And the reason that I can do that is because this is your 3rd chemistry course, so we won't really have a lab safety class. I will remind you about lab safety, but we'll do that in the first lab. So rather than have you guys come in, you know, drive to campus, get your face shields and masks, and come in for 15 minutes while I do safety, I'm going to join together lab safety and lab number 1. So this will be covered more in lab number 1. And lab number 1 is not next week, it's the week after. So you can sleep in next Tuesday. We won't have a lab next Tuesday. All right, isomers, come on, slides. Okay, so molecules in where no carbon is connected to more than 2 other carbons are called straight chain hydrocarbon or continuous chain hydrocarbons. I'm going to draw some pictures there for you now in a second, and you're welcome. I'm just reading the comments there or the chat, and no problem. It's good for me too. So I'll draw you a continuous or straight chain in a second, but a branched chain is exactly what it sounds like. And I'm going to imagine that the word branch comes from the fact that it looks like a tree branch. If you can picture a tree, you know, not a lot of trees around, but there are trees here, and a branch where things stick off of the main chain or the main branch. You have we call them twigs, but little things sticking away. So just, let me draw you some. Let's take hexane, one of my favorites. So C6H14, hexane. So, all right, I'm going to draw a continuous chain here. So I put my pen down, 1, 2, 3. Uh-oh. Uh-oh. Okay, hold on. Pen issues, pen issues. 1, 2, 3, 4, 5, 6. Sorry about that. This is going to be very annoying with this pen. So let me just count again. 1, 2, 3, 4, 5, 6. All right. This is a continuous chain. Now, I can draw from this an isomer of hexane, an isomer of a 6-carbon chain. It will have the exact same number of carbons and the exact same number of hydrogens, but I'm going to make a branch in it. And actually, one of the easiest things to do is just take a piece off the end and stick it somewhere in the middle. So watch this. So I'll go, my pen, I'm going to cry. 1, 2, 3, So 1, 2, 3, 4, 5. Okay, and I can just put a branch there on the 4th carbon. And actually, if we were naming it, that would be the 2nd carbon, but we won't get into naming today. So this would be a branched chain. This still has 6 carbons. There's another one up here at the top. Yeah, that's it. And we could make more branches, and I'll get into that when I do isomers. I don't have a lot of, or when we start drawing some isomers. I don't have a lot of room on this slide, but there you go. These would be isomers. Exact same chemical formula, but they would actually have completely different, well, similar but different chemical properties. So this chemical wouldn't behave the same as this chemical. Pretty cool. I'll get into naming later, but they would have different names. They wouldn't both be hexane. So here's a simpler example. Here's butane. And in butane, we have 4 hydrocarbons. Okay. Oops. And all I did was I took this last one, stuck it in the middle, 1, 2, 3, and there would be our other one up here. So it still has 4 carbons, still C4H10. It would just have different properties. These are isomers, completely different structure, same chemical formula. Let's just name them for fun. You guys might not think this is fun. I think it's fun. We will get into naming in chapter 2. So if any of you guys are confused, you're kind of meant to be right now, because we haven't done this yet. So we would call this guy butane. This would be if any of you have a lighter around, typically the liquid in the lighter is butane, or a torch. I know some people in the kitchen use like butane torches. Propane would be another similar chemical to this that you would use when you grill outside, or if you have a propane stove inside. So these are natural gases that we use to generate heat. Now, I could take this chemical. This is only 3 carbons in my longest chain, so this would be called propane. But it's not just propane, because there is a methyl group on the 2nd carbon. So we would call this 2-methylpropane. And we will get to this in chapter 2. Oh man, my pen. I got to figure this out. I've talked to Microsoft and I don't understand. Anyways, so we'll talk about naming in chapter 2. You guys do not have to worry about naming for now. So this is really interesting. This is like a mathematical calculation, and I'll leave this for the math people, the math department, to do the calculations for this. I got this obviously from a book, but the number of isomers possible grows rapidly every time you add a carbon. So methane, you can't draw methane any other way. There's only one carbon. Ethane, you can't draw any other way. It's only two carbons. You can't connect two carbons in any other way but to each other. And I'm not talking about double bonds or triple bonds. I'm just talking about connecting the carbons. Now, when you get past propane and you get into something like butane, you can have two possible isomers. You get up to 8 carbons, you can have 18 isomers. 15 carbons, 4,347 isomers. So 15 carbons, you can have over 4,000 combinations. It's incredible. And then when we get something even crazier, like 30 hydrocarbons, you can have, what is that, 4 billion combinations, 4 billion different ways to connect 30 hydrocarbons. Pretty cool. Now, for you guys in chemistry 2420, we will keep the number of carbons to about 10. And I'm obviously not going to ask you to draw all isomers for octane, for example. Like I would never do that. But wink, wink, I might give you something like hexane or heptane or even pentane and ask you to give me maybe 1 or 2 isomers. All right, and we're going to do a practice problem now. 1, 2, 3. There's 3 practice problems that we'll do. And then I'll check the time. Again, this is a beautiful course. We don't have to rush anything, so I'll try to keep my classes pretty quick. And we'll see how we're doing after these practice problems. All right, so actually this is a good little warm-up practice problem for us. I recommend maybe now, if you have a minute, to grab a pen and a piece of paper if you have it around. You should have pen and paper somewhere in your house or apartment, but we're going to do these together. And I'll probably do the first one for you, and then you guys can try the other 2. Okay, write the molecular formula and the skeletal formula for 2-methylbutane. So this is actually not an isomer question. This is just practicing writing molecular formula and skeletal formula. This will be a little challenging when I give you your assignments. Your assignments are online, and I don't like taking paper assignments because students take pictures of them and send me these blurry pictures that I can't read, and then I can't mark them because it's a picture. And what I'm saying is your assignments that are online, you won't have to draw a whole lot of structures. We'll save that for the lab where you can draw them on paper and I can mark them on paper. So a lot of these questions that you see will end up being multiple choice type questions because you can't draw in D2L in the quizzes, as far as I know. All right, molecular formula. This is the easiest thing ever, guys. All you do for molecular formula is count. So let's start with carbons. 1, 2, 3, 4, 5 carbons. So this would be, I'll do it over here. Actually, guys, give me 1 second. I'm gonna do something. Sorry. Oh, sorry. I'll share my screen in a second. I'm just gonna move my drawing so I can draw it better. All right. Sorry, I'm just gonna get Zoom open. I'm talking to myself like a crazy person. All right, here we go. I just moved the picture over so I could draw this a little better. All right, so 1, 2, 3, 4, 5 carbons. So this would be C5. All right, let's count the hydrogens. Now, if you know what you learned in 1121, you should, or well, you might remember from 1121, if I have an alkane, meaning all single bonds, and I have 5 carbons, the number of hydrogens would be times the carbons by 2 and add 2. So it would be 2n plus 2. I don't really care if you remember that because again, we're going to be drawing these, so I can just count, and it should be 5 times 2 is 10, plus 2, 12. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. If it wasn't 12, I would have a big problem with my structural formula. So guys, just if you were curious, the formula for alkanes, not alkenes, is CnH2n plus 2. So if I had 10 carbons, it would be 20 plus 2 hydrogens, so 22 hydrogens. You do not need to know that or memorize that, because again, the purpose of this course is we're going to be drawing skeletal. Okay, skeletal. So what I'm going to do is I'm going to draw the 4 of these together. So 1, 2, 3, oops, I think I just did 4. I went too far, sorry. 1, 2, 3, 4. There's 4. Let me pick a different color here. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and notice on the second carbon, I have a little branch sticking up from it. And this is really important. This is something that a lot of students do, which drives me crazy. Ooh, that's not very pretty, is it? Okay. So this is the skeletal formula. Now, what drives me crazy is when students do this. Oh, well, my pen drives me crazy, I'll tell you that. This drives me crazy. Do not do that. Don't put the carbon branch in between the 2 on the bottom. Do not do this. It makes Mark cry. And you do not want to make me cry. Do not do this here. No, 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 no. Okay. I have students who've done it. I give them a mark anyways, because I'm, I don't know why. But anyways, don't do it. Please don't do it. Do this. This makes me very happy. All right, cool. So if that's cool with everybody and you have a piece of paper there, whoa, cool. Ali just in the chat basically gave the formula using some subscripts, some fancy text in the chat. That's cool, Ali. I like that. Anyways, yeah, let's look at these practice problems. Sorry, I get distracted by cool things. So this is a really good problem, and this is an interesting problem because I love the answers I get for this. And I'm going to put myself on mute for a minute, and I think I might try to pause the recording to see how that works for my YouTube video, but I'm going to put myself on mute for a minute. And if you guys have a pen or a piece of paper, try to draw all 3 isomers for pentane here. Now, that includes pentane itself. Okay, so you would draw pentane and then the 2 branched isomers. This is a very tough question. So let's see who can do it. I'm just going to mute myself, so I'll shut up talking and you guys can take a few minutes, and I'll be back in 2 minutes. All right, so just kind of finish up what you're doing. Ooh, we even got some names there. Yeah, and the naming that you're doing, Ali, is interesting because we're going to look at naming some of those things. ISO, I don't know if we're going to do NEO. It's excuse me, it's not part of the branches that we look at, but yeah, that's cool. That's good answers. If we were in a real class, sometimes I'd get students to come up on the board and do this. And I know in Zoom, you guys can actually draw on my screen, but I find it confusing because multiple people try to draw at once. So let's just kind of look at this together, and I'll do the drawing and explain. explain how they draw. Actually, yeah, Ali, if you want to draw, you should be able to annotate on my screen. You do not have to, but if you want to, let me know in the chat. If I don't hear from you in a minute or like 30 seconds, I'll just draw them myself. Yeah, okay, you can draw if you wish. Or do you not want to draw? I'm confused. I don't know if everybody has the ability. I guess you could use your mouse or whatever. I have like a fancy pen. Yeah, okay, there's one. Ali just drew pentane. That's awesome. That's better than I can do almost. That's good. Oh, and then there we go. Oh, there's your other isomer. That's the one I expected most people to get. Now, I would name that a little differently than Ali named it. Ooh, this is my favorite. Oh, Ali, you did the thing I told you not to do, but you are correct. That is the answer for sure. I would draw the last one a little differently. No, your drawings are good. It's just where you put that other methyl group. But I mean, this is a tough question. Thank you very much, Ali. That's like 10 out of 10. Or maybe 9.5 out of 10. Whoa, don't, oh, he's erasing them. Okay. Yeah, okay. So, all right, we'll leave your answers there. So guys, this is pentane. This is perfect. Let me change my color so it's not in red here. That's the first time I've had somebody do that. I love it. All right, so perfect, no problems there. This would be Ali's version of N-pentane, which in this course, we just call pentane. There's different naming conventions that people use. In IUPAC, which what we're using, I think we would just stick with pentane, or N-pentane is fine as well. This one here, perfect. I would call this 2-methylbutane, okay? And we'll worry about naming later. And then this one, almost perfect, but what I would do is, and this looks really weird, guys. You're gonna kind of, oops, sorry, that's my dog. Must see a cat or something. This one, I would draw my branches like this. 1, 2, 3, and then you have 2 other groups there. All right. Sorry about my dog. Yeah, we got a Picasso here. So, but Ali, and to everybody in the class, this is fine. I wouldn't take marks off for this. I don't like it, but it's totally fine. And if we were going to name that, we would call that 2,2-dimethylpropane. But guys, do not worry about naming. All right, I think I'm going to do this last example, and thank you for that, Ali. I'll do this last example, and then you guys are free to go. Now, rather than get you, I mean, Ali could draw it again, anybody could draw this again, but just to save us a little bit of time, I want to talk about this one, and I want to put a star there, and I want to wink, wink, wink that you guys might see this in the future, this question. And the reason I like this question better than the last question is the last question only had 3 answers, and I asked you all to draw them all. That can be quite challenging. This, I like 2 questions, but I want to be clear here. This is where a lot of students lose a mark for me, okay? This says draw at least 2 isomers of heptane. And be careful with the English there. What I mean with this question is I want you to draw isomers from heptane or of heptane. I do not want you to draw heptane. So basically where a lot of students go wrong is they see this on a test and they draw heptane. 1, 2, 3, 4, 5, 6, 7. So this is heptane. If you don't know that heptane has 7, we're going to do that next class. We'll talk about the series from 1 to 10. But I want 2 isomers of heptane. I don't want you to draw heptane. And this, like I said, wink, 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 you might get the same question on a future test. I might say octane, I might say hexane, but you'll get a question like this. So don't give me this, give me an isomer. Guys, there's a bunch of isomers for this, so I could draw 6 carbons. I gotta count, I can never do this in my head. And then I'll take the guy at the end here, and I can put him on the 5th carbon. 1, 2, 3, 4, 5, 6. I can put him on the 4th carbon here. You could take, there's so many isomers. You could take 2 carbons off. So like another one, I'll do up top here. 1, 2, 3, 4, 5. You could do this, right? As long as you have 7 carbons, oh man, my pen. 4, 5, and then 6, 7. As long as you have 7 carbons total, it's going to be an isomer. So these two are probably the simplest ones. 1, 2, 3, 4, 5, 6. And I want to leave you with one thing today. Once I stop recording, I'll ask if anybody has questions or if anybody's confused. But I want to leave you with one thing today. If the chemicals you draw have different names, they will be isomers. And the reason I say that is I have students sometimes, they actually draw the same molecule twice, but they might flip it, or, it might be flipped over, but it's still the same molecule. So as long as they have different names, they are isomers. Okay, now, okay, and they must have the same number of carbons as well. But if your isomers have different names, they are different isomers. We haven't done naming yet, but we will next week. So I'll kind of come back to this next week, and we'll talk a little bit more about naming and then how you can know that your isomers are different. Okay, so I think that's it for me today. I'm going to hit stop record, and if anybody has questions, you can let me know, because we still have 10 minutes or so left if you have questions. All right, so I'm gonna hit stop, say goodbye, have a good weekend.